Good evening, class. Welcome to a lecture on microscopy under biophysics. Yes, my email addresses are here. My telephone numbers are also displayed. By the end of the lecture, students should understand and be able to define microscopy, discuss the principles of light microscopy, and outline the function of the parts of the microscope, demonstrate proper handling of the microscope, and answer exam questions and midterm questions on microscopy. What is a microscope, or what is microscopy? Before we zero in into the functions of microscope or what microscopy is, we would like to watch a short video.
Demonstrating parts and operations of a compound light microscope.
So what to demonstrate the parts and functions of a compound microscope.
Whenever you pick up the microscope, you hold the arm and support the base.
So when you want to lift the microscope, you hold the hand and support the base.
And they can be adjusted out.
Yeah, these are the eyepiece. They are called oculars. Ocular lenses. They have magnification of 10 times 10. The revolving nose piece is this one.
Each of the lenses you see.
Yes,
On the
that's the
revolving
nose piece. That's where the arrow is. That's where the her finger is.
3 objectives, a 10x, a 40x.
So this microscope came with 3 objective lenses.
Below the nose piece.
So these are the objective lenses.
On the stage there is a clamp.
This is the mechanical stage, which has a
Below
clip.
the stage, on one side,
Yes.
there are the stage moving controls.
So these are stage
One
controls.
control moves the stage
Stage
back
controls
and
where
forth.
she's touching.
The lower control moves the stage right and left.
So we can move the stage
These
horizontal.
dials move the stage up and down to help focus your specimen.
So this is the coarse adjustment
moves
knob.
the stage quickly. The fine adjustment
This is the fine adjustment
moves the
knob
stage in
for
much
fine
smaller
tuning
increments.
of image. The condenser controls the amount of light
And underneath this
entering the
hole is
microscope
condenser. If we look
or
underneath
entering the
stage,
objective.
see the condenser is up here.
So that's the
The
condenser.
condenser can be controlled and moved
You
up
can
and
lift
down.
it up and
For
down.
most applications, all the way to the top is the best position. On the condenser, there's also a small lever. This is
The condenser has a
iron
small
diameter,
lever for
and it
regulating
controls the amount of light
the
that
aperture
passes
or the hole inside the condenser. The light intensity controls.
Directly below the condenser is the light source.
So this is the light source.
On the front of your microscope, there is a switch.
This is the on and off
Turn on
switch.
the light source. And on
Then
the
you
side
can
of the
regulate
microscope, there is
the intensity of the light
a dial.
from the side. This is where you
Turning
regulate
this
the
dial up
intensity of the light.
increases the brightness
So
of
you
the
can
light
increase the
source.
brightness
When you use your
or
microscope, it's
dimness
best
of
to
it.
start with the light relatively low, and you want to start with the lowest power objective in place.
So how do you clean the
When you're
microscope?
finished using the microscope, make sure that you clean it.
When you finish, you have to clean with the lens
We'll use
paper.
lens paper.
Clean all the lenses with the lens
Remove a
paper.
sheet of lens paper, and
Or-
you can wipe off the
So
oculars.
she's wiping out the oculars or the
You can also
eyepiece.
wipe off the objectives.
The objectives are 3 times 10 times 40 and times 100.
If you use oil on your microscope,
This oil
use
immersion.
lens cleaner
Oil.
to clean off any oil.
So oil and also immersion.
And rub to remove any oil.
This is a lens cleaner. This
If
detergent
necessary,
is
you
a
can
lens
also
cleaner.
wipe the condenser.
This is wiping the stage and everything. How do you store a microscope?
Put the microscope away. Begin by turning the light all the way down.
So before you store it or put it back, you turn off the light and off it.
Then rotate the nose piece so
Rotate
that
the
no
nose
power
piece
or low power objective
so that the low
is above
power,
the
that's
stage,
times 4,
and lower
will
the
be
stage completely.
will appear. Then you lower the stage.
Finally,
We'll move
wrap
the
the
wire
power
from
cord
the mains or
around
electricity.
the base of the microscope.
Wipe it up, turn it around the base of the microscope. Then you can hold the base and the hand, the arm, and go and store it. So we resume by defining what a microscope is. Microscopy is the science of investigating small objects using a microscope. So you want to see how a small object like a unicellular organism looks like. Microscope. Microscope is an instrument for viewing objects that are too small to be seen by the unaided eye. Unaided eye is an eye without a spectacle or a telescope or magnifying lens or whatever. Giovanni Favre coined the term microscope. It is a precision equipment which resolves and magnifies objects. Microtome is a device used to cut thin slices of tissue for microscopic study. We will not be tackling microtome, but we will just be mentioning it because you do it in histopathology. So a brief history. 1590, Zacharias Janssen and Han Lepesche, Dutch. They are Dutch, they are from Holland. They were spectacle makers who found that many lenses in a tube produce a much larger image than the individual lenses. So they realized that with the spectacle lenses, if you put it in a tube like this, it gives a magnified image than the lenses without the tube. So Zacharias Janssen invented the first microscope known as the optical microscope. Most of the time, most of the optical microscope or simple microscope have only one lens, only one eyepiece lens, and one objective lens. So 1595, Robert Hooke, an English father of microscopy, used compound microscope. He discovered cells in living things using the compound microscope. This is a microtome. We'll see it in histopathology. Anthony Leeuwenhoek, father of microscopy, made the first single lens. And anytime you see a single lens or simple microscope, it has only one lens, one objective lens, one eyepiece lens. He saw bacteria, prototists, sperm cells, blood cells, microscopic nematodes, and rotifers. In the 19th century, Carl Zeiss also devoted significant effort to the manufacture of microscopes. So you can see most of the modern microscopes, especially those used for histopathology or by pathologists, they have the name Zeiss on them. It's now a brand. Ernst Abbe, who carried out a theoretical study of optical principles, and also Otto Scott conducted research on optical glass. What is a bright field microscope or bright field microscopy? Is the use of light microscope in a well-lit background. For dark field microscopy is use of light microscope in a dark background. Phase contrast microscopy explores the differences in the amplitude of light to see components of unstained structures. So let's see the examples below. So when we say bright field microscope, this is the object or specimen we are looking at. You can see a purple color with a blue boundary around it. This is the object. And this white thing around it is the environment or the field. So the field is bright, that's why we call it a bright field microscope. Then for the dark field, you can see that all this is dark and the object is inside, but the field is dark. Then the phase contrast, you can see it's a contrast of phases using different amplitude of light. So you can see this same object, you can see it as what? This color. Looking reddish, greenish is the same color. And the environment or the background is like green. So this phase contrast, we contrast the phase or use it depends on the amplitude of the colors that we are seeing. So let's go to fluorescent microscopy. Is the use of fluorescent dyes, fluorophore, fluorescein, rhodamin, to eliminate components of structures. Magnification is the product of objective lens magnification and ocular or eyepiece lens magnification. The ability to distinguish between details of structures. Resolution is the ability to distinguish between details of structures. Resolution is how fine something looks like, or how fine the microscope is able to bring a detailed structure or detailed image of whatever organism we are visualizing. The effective resolution of light microscope is 0.25 micrometer, and that's the formula there. Don't memorize it. It's not for you, it's for biophysics. Okay, so these are the examples. So let's see fluorescent staining. So we see this one in the next slide. The explanation is in the next slide. Thank you very much.